Example 6 is actually rather interesting. So we have a uniform magnetic field, magnitude B naught, that varies with time, and it's pointing up. Okay. So we want to figure out. So it fills this circular region like this, and all the magnetic fields are pointing up. And we want to figure out what the electric field is on this disk. Okay, it's uniform. And so we just use an Amperian loop. Even though we're not using Ampere's rule, we're going to use an Amperian loop, and then you calculate the flux and use this little identity that the E vector. We don't have any free current, so the divergence of E is 0 by dt. Okay, so let's take some loop inside there, some arbitrary loop. We're going to calculate the total flux through it and how it changes according to time. This has a radius, of course, of r. Okay, so we get n is equal to the change in flux. So the flux is 2 pi r. I'm sorry, pi r squared. They're not times b naught. And then we're taking the time derivative of that, so that's the minus d by dt. This is messed. Let me do it again. So it's equal to minus d by dt of pi r squared b naught. Varies according to t. And that'll give you, well, the E field is going to be constant all the way around, so E times 2 pi r. So E is equal to, well, the r is not going to change over time. So we get r over 2, we have a minus sign, yes, d by dt of b naught of t. And that is our electric field at radius r. So the direction it's pointing, of course, Lenz's law. So if we run with our area vectors pointing up, then the E vector is going to be pointing along with phi. So negative, so if the magnetic field is getting bigger, then it's going to point backwards. If the magnetic field is getting smaller, it's going to point that direction. So, cool. I got that wrong, actually. If B naught is increasing, so B is getting bigger, then it's going to try to oppose it by running clockwise. Yes, I got it right. I got it right. Okay. So use Lenz's law too. So if the B vector is getting bigger, you have to create a current. It goes this way to create a magnetic field pointing down. If the B vector is getting smaller, then you have to create a current this way to increase the magnetic field. There you go. Thanks for your time. Bye.